Okay, Robert, can you hear me? Robert? Robert, please say something. Okay, welcome, Ismail and Robert. Can you hear me? Test, test.
Hello?
Hello? Can you
Okay.
hear me?
Yeah.
Okay, good. Thank you. about you, Ismail? Can you hear me? It's there. Well, I just couldn't recognize you. You said something, but go ahead, try to say something. Hi, Ismail. Can you hear me? Check, check.
I don't know if they're there.
Yeah, I can hear you, Robert. No problem.
Okay.
Yep. How about you, Ismail?
Hello?
Hello? Yes, crystal clear. No problem.
Sorry, I was having trouble with my mic.
Yeah, I can hear you now.
I don't know if you noticed, but everyone is muted. Just to make sure.
Yeah, I have a mic control, so
Okay.
if I need to mute everybody, I'll mute. But you can unmute anytime you want to.
I see. And hopefully the students join.
Yeah, because we still have time.
Yeah.
Class starts from 1. Don't worry about it.
Okay.
Okay, looks like I'm welcoming a few more students. Can you hear me? And then please just go ahead, try to say something. Check your audio. Zach and Marcelo.
I can hear you.
Yep,
I'm in
yep.
the library though, so I won't be talking
Oh,
much.
okay, yeah. It's crystal clear. I can hear you too.
Yes, I can
How about?
hear.
Okay, good. Thank you. Class begins in 5 minutes, just a minute, okay? Okay, also, Caleb, can you hear me? And then try to say something. And also, Ian, welcome. Can you hear me? Let's check the audio. And Kaidi is here too. Go ahead, say something. Okay, good. Go ahead, try to say something. Unmute your microphone.
Hi there.
Hi, Michael. Kaidi, can you hear me? Say something.
Yes, I can hear you.
Okay, good. I can hear you too. Great. It's just a check-in. The class begins in about 4 minutes. Okay, Caleb, assuming that you're hearing, but we're not going to do chat box. It's not necessary for lecture, and then students usually misuse it. So if you don't have a microphone, please get it, because you cannot ask question if I do online session, or if you are sick, need to participate online. If you don't have a microphone, you cannot ask anything. So please, I would recommend you, highly recommend you get a microphone. You can react, by the way. Caleb, can you try to react it? If you understood, just to do like a sum up or something, there's a reaction button somewhere. Go ahead, try to react, indicating that you understand. Okay, good, thank you. All right. All right, so quite a few people actually joined in. Still, I'm waiting for 8 more people, but if you joined in, try to unmute your microphone, say something. That's just to check your audio. And I just want to double check you are hearing me too. Who's coming in?
Hello? Can
Hello?
you hear me?
Yep, I can hear you.
Cool.
Who else?
Hello?
Hi. Yep, I can hear you. No problem.
Hello?
Hi. By the way, how's my audio, the quality wise?
Audio quality is great.
Okay, good. Thank you. Okay, still 5 more people to show up. Now it's 1 o'clock. Now at this moment, I'm going to start calling to the people who do not show up. Okay, down to 3 more people. So I started to try to invite them to join in. Okay. All right, good. Let's just get started. All right, welcome everybody. So now you are seeing my desktop at the same time, watching my face too. I turned on my webcam. Can you see me? And can you see my desktop at the same time? How is my audio quality? If you want to say something, just to go ahead and mute your microphone anytime and then start saying something. How you doing?
Everything is great.
Okay, thank you. All right. So this session is already recorded, so I'm going to get going, okay? All right. So I'm going to switch over to this pen tablet right here. So today's second day of the semester. Okay. Just a minute. Just a second. So to begin with, I'm going to mute everybody. So if you want to say something, just go ahead and mute your microphone, start saying something. So I'm going to mute everybody for a moment. Okay, good. All right. So to begin with today, let's just take a look at updates. I'm always going to begin with updates. There's no new updates. You already know. Here is a new announcement. Monday, August 30, and then I hope you finished quiz 0. I hope you have finished or you did something, you tried to do something, you struggled, I don't know, you yelled at and you scratched your head, you banged your head and against the wall, I don't know. You did something and you submitted quiz 0. Obviously, this is something I don't expect anybody to do a perfect job. This is just the diagnostics, but I just wanted to let you know that those are the kind of problems that I would expect you to solve it along the way. At least the first 1/3 of the semester, I'm going to spend some time, some significant times, trying to review fluid mechanics and also some other fundamental concepts, which is essential to aerodynamics, essential to any engineering, but particularly aerodynamics. Now, anybody can claim that, hey, I'm airplane guy or airplane person because that's my hobby. I've been designing, building airplane, flying. Always, I know what I'm doing. Is it true? I mean, so that means you can get a job and then start designing airplane and start flying passengers. Not really. You have to set your foundation so that if something is designed, that design is not because of your instinct based on some kind of solid analysis and data, and then decisions done by fundamental idea of physics of flight. That's what you need to be doing. So everything is coming from mostly fluid mechanics, yet this is the time that you probably realize that, hey, do I really understand fluid mechanics? The heck no. I must do something. Let's do something, okay, starting from today. So don't worry too much about quiz 0. This is just the diagnostics. Everybody will screw up, I know that. Don't worry about it. I think it is up to you picking up the terrible quiz 0. I'm going to quickly grade it. I can quickly grade it because there's no way that I can give you partial credit for wrong numbers. If you get wrong number, you get 0. If you get the right number, you get 1. Kind of quiz, right? So it's very easy to grade. You're not going to get much partial credit. And also another thing, I'm not going to give you any solution for this quiz 0. Okay? So you are going to figure it out along the way as I cover certain things in class. Then you all of a sudden start thinking about, okay, well, quiz 0, I completely screwed up, but wait a sec. Now I'm getting it. I feel like I can solve this quiz 0 problem 1 because Dr. H covered something today that actually clicked my mind. Oh, okay, that's something I need to be doing. So you're going to figure out, okay, those quiz 0 solutions. If you don't do that, there's no hope. Okay? There's no hope. You don't need to be an engineer. So take it seriously. Okay, so let's get going. So today, I'm going to start Unit A1, Engineering, very, very fundamentals review. Let's just review those things. What kind of things I'm going to review? Number one, let's just talk about what is aerodynamics, well, just briefly, because if I can explain what is aerodynamics in one class, I mean, you don't need to take this class anyway, so you have to figure out what the hell is aerodynamics as a big picture as you study years and years and years. Maybe you get a job, continue learning, and then you kind of someday realize, oh, okay, now I kind of get overall picture of what is this aerodynamics is all about, kind of thing. So let's just take a look at the brief overview to begin with, okay? And then today I'm going to emphasize this subject. Let's just take a look at here. Engineering units. This is probably number one issue right now. This is probably quiz 0, problem 1A, problem 1B, isn't it? So I want to ask you a question. Feel free to, okay, unmute your microphone, say something. But what was the impression by looking at problem 1A, 1B? What was your impression? Was it, oh, yeah, I know how to do it? Or, what the hell is this? Or, I have no clue even where to begin. What is your reaction of problem 1A, 1B, of quiz 0?
For me, oh, it's Robert.
No.
For me, I understood it, but the issue was trying to find the right constant. R constant.
Constant.
The
What
R
constant?
constant. The R constant
R constant. What's R constant?
for the ideal gas equation.
So this is gas constant?
Yeah, gas constant. The ideal gas constant.
Oh, sorry. So what kind of gas constant did you need?
I needed the one for air, but in terms of English units.
In English unit, 1716.
Yeah.
Yeah, foot-pound. Slag ranking. Anyways, we're going to cover that, okay? So that was your issue.
Yeah, that was my main issue that set me back a little bit, but after I found that, yeah.
Anybody else?
My big issue was with the first problem, how it was asking for pounds and mass and then pounds as a weight. And I'm like, are you asking it in slugs or are you asking like pound mass and pound force?
So you're saying pounds. Okay, what kind of pounds are you talking about? It could be like a kilograms. What kind of kilogram you're talking about?
Exactly.
Yeah, that's right. So that's something we're going to talk about that today. Okay, anybody else? Okay, so something similar. So you can react. Okay, well, I'm with you, man. I felt similar way. We want just to react, just a thumbs up or raise your hand or clap or something. You can go ahead, try to react. How do you react it, by the way? Let me show you. Okay, so this is you. I'm watching you. Okay, so here is a react button here. So you can either laugh, applause, hurt, like, or raise your hand. But if you raise your hand, you have to make sure lower your hand. How? Quick again. Okay, so go ahead, react, everybody. Okay, Okay, good. Thank you. Thank you. All right. Okay, good, good. So, by the way, if you raise your hand, don't forget to lower your hand because it's just going to be there. So I'm going to say, well, you keep raising your hand. Do you have a question or something? Okay, anyways. Good. All right, so let's just move on. So I'm going to start with what is aerodynamics? It's a huge study discipline area, and no one person can cover everything. We have quite a few actually professors here at Embry-Riddle. They claim themselves I'm aero. But within even aero, there are several different subcategories here. Okay, so when you talk about aero, we can talk about those kind of things. Density, viscosity, velocity. Density could be constant. If the density is constant throughout flow field, it is called incompressible flow. Okay. What is the category of incompressible flow? It is actually connected to the velocity too. If the velocity is low, I'm talking about in terms of Mach number. If the Mach number is less than 0.3, we can basically assume that incompressible. So less than 0.3 Mach number is oftentimes called subsonic, incompressible subsonic flow. Okay. What is the great benefit for that? We can massively simplify our equation. Okay. Also, another thing is oftentimes viscosity. Do you guys know viscosity from fluid mechanics? Of course you know. Anyways, I'm not going to cover anything from fluid mechanics. You figure it out, okay? If you don't know, you just go back to your fluid mechanics notes. Anyways, viscosity of air is very, very low compared against like liquid. So viscosity is oftentimes ignored. If so, it's called implicit flow. Now, air comes with viscosity, of course. So if you include the viscosity, you are going to actually start analyzing something called boundary layer. Okay. So if you start analyzing boundary layer or boundary layer becomes significantly important, it is called viscous fluid or flow. You're going to cover those things not in this class, but Aero 2. Okay, anyways. And also, you have three different approaches to solve the problem in aerodynamics. One is, of course, analytically solving problems. The other one is experimentally solving problems. Third one is numerically solving problems. Those are three different subdisciplinary areas of aerodynamics. Those are three different ways of approaching to solve the problem. So anything in red font here, let's just zoom out a little bit. Okay. Analytical solution. Density is constant. Velocity is low speed. The problem could be 1D, 2D, 3D problem, or problem could be steady or unsteady or periodically unsteady, could be either problem. But you are looking at the red fonts. This is aerodynamics 1, aero 1. We're going to cover those. So heavy emphasis on low speed, and then oftentimes ignore the viscosity so that treat everything implicit, and then heavily analytical. Analytical means you're going to use mathematics to solve the problem. Okay. Now, there are a few more things I want to add. Experiment. Of course, if you're aerotrack, you're going to take experimental aerodynamics, mainly wind tunnel test, but it may include prototyping and flight testing and mock-up and other things. Those are different class, experimental aerodynamics. Okay, of course, if you're aero track, you're going to take those classes probably next semester. The other one is a special subject area, numerical simulation. This is oftentimes called computational fluid dynamics. This is computer simulation. This is something actually I do as my special field of research. So I do have a research lab downstairs of this building, B76 STEM building. Room number 121 is my research lab. That room, we have a bunch of very powerful computers. We are going to try to solve the equations governing the flow field, trying to simulate using the computer. Not to solving it, but to trying to simulate using the computer. So that's called computational approach. Nowadays, this is getting more popular because we have a better computer available. However, important thing is, if you zoom out and take a look at the big picture, okay, without the red font being properly taken care of, you can never move on to the blue or green. People just to try to jump right on to, okay, well, here I am. I'm at the wind tunnel. I'm going to test something. Anybody can say that. Anybody can try that. Even high school kids over summer, okay, Aerodynamics camp or something, the local high school kids come in, and then I'm going to let them play with wind tunnel. Do you think they can do a job? Oh, cool. Let's flip on the tunnel. Let's just do something. Oh, by the way, it looks cool. That's it. Today's over. So what kind of data did you take? Well, what's the data? So again, AE301, this is very, very important foundation block. If you are serious about moving forward with the profession of aero track in aerospace engineering, trying to get a professional job in that area, this class is something you must master. Master means serious business. That means you really do understand, have a real skill. Now, have a real skill means that, suppose if you are getting quiz 0, and then this wicked Japanese professor says, okay, well, here's the problem, 14 pages. Go ahead, solve it, turn it in Wednesday. I give you a day and a half. Oh my goodness, he's crazy. No. This is going to happen on day 1 when you get a job. Are you ready for it? So let's just start from this class. Okay, your boss will do the same thing on the day 1. Then what's your response? Oh, I just couldn't even solve anything, or I just didn't even submit. You're fired. Okay. So be serious. Just to do your best, whatever it takes. There's no way you can pretend like, hey, I took aero class, I passed it, who cares? Somebody will care seriously about, hey, this is the real problem. What do you think? How do you approach? That is the question you will receive. Can you handle that? Well, you can never handle it unless you understand and mastery with the mastery skills of aerodynamics, right? That's what you need to develop. So this semester is you're probably welcome to the real world, day 1. Okay, so let's move on. Next page. So let's just talk about engineering units today. Let's just focus on problem 1A, 1B of your quiz 0. Okay, so what is the engineering unit? We are going to, let's begin with, okay, what is the foundation of engineering units? I'm going to use a blue font, okay. So anybody, please volunteer. Wrong comments welcomed. Where is the origin of engineering units? Why do we need such a thing? What does that come from? Remember fluid mechanics class? Okay, what is the beginning of the section of the lecture in fluid mechanics that the professor started to talk about engineering units? Where did you begin? Anybody, please volunteer. Your long comments are appreciated. Go ahead. Anybody?
Michael here. We started out with just mass and length and just saying, okay, here's a mass and here's a length and versions.
Good point. Good point. Actually, not so bad. So you're talking about basic dimensions. Do you remember this? We have basic dimensions in engineering. He mentioned about mass. Mass is m. Do you remember that? And then he talked about length, which is the L. And then what else do we have as the basic dimension of engineering?
Time.
Time, great. That's correct. And also one more is a temperature. We oftentimes use independent with theta. So this is temperature, okay? I'm not going to use T because the T is taken for time. So this is temp. So why those are the basic dimensions? Basic dimensions are the dimensions that everything else, the engineering units, quantity that you want to specify is made up of those basic dimensions. Something made up out of mass and length time, what is it? Important thing is a force. Do you remember the force? Force is made up unit by mass and length time. What is the dimension of the force made up of?
Mass over time square.
Oh, close. Mass multiplied by length. Divided by
Time squared.
time square. Mass times length divided by time square is the force. So when you think about the unit of the force, that unit is made up by mass and length and time. Combination mass times length divided by time square. So that's the beginning, the very beginning of engineering units. So we are going to take a look at the two different engineering unit systems somebody defined, which one of them you may not like it, but somebody defined. So we have a two different kind of engineering unit system. One is SI. This is an international standard. Well, actually, this is Système International, something like that, the French word. So this is standard of international SI unit system. So I would say international standard. Although original language is French. The other one is a stubborn one. What is it?
British.
British. Okay. So this is something called US Customary or British Engineering Unit. British Engineering, BE, okay? So those are the two different kind of unit system. Let's just zoom in a little bit. So I'm going to list the standard unit, okay, for mass. Okay, standard unit for mass. And standard unit for length. Standard unit for length. And standard unit for time. Standard unit for time. And then, of course, using those mass and length time, you can create force. Of course, if you use all the standard unit, you are going to develop standard unit of force, of course. Force is made up unit. Okay, and let's not forget temperature. And temperature. Okay, so I'm going to basically keep using the blue fonts, specifying that, okay, so what is the standard unit for mass in SI to begin with? Let's just to begin with it. Anybody?
Kilogram.
Kilogram. kg. This is standard. What is the standard unit of length in SI?
So for length, for
Length.
SI, meters.
Meters. Lowercase m. Meters. It's not
Time.
centimeter. It's not the millimeter. It's not the kilometer. It's meters. Okay. That's the standard. Okay. Standard unit of time in SI.
Seconds.
Seconds. S. So I keep using the word standard. That means if you calculate something, the number associated with must be associated with those units before you punch those numbers. Suppose if somebody give you gram for mass, kilometer for length, hours for time, you cannot simply pick up the numbers associated with those non-standard units and punch the number into your calculator to get the results out. No, you can't. You have to first convert gram into kilogram, kilometer into meter, hour into seconds. So of course, you're going to have different values associated with those standard units. Use those values into your calculator. That's you must do that no matter what. Okay, that's what we call standard units. Okay, anyway, so let's just move on to this side. What is the standard unit for mass in U.S. customary unit?
Slug.
Now you go like slug. So I start getting confused because I'm Japanese. You know, before I came to this country, I never used the slug. But you guys are Americans, you know, you use the slug all the time, right? You go to Walmart and say, hey, can I have 2 slugs of apples, please? Then you know, well, no, we're not going to do that. But you say it's a standard, right? Do you use it? Do you use it?
No,
Do
we
you?
only use
No, you don't
pounds
use
as
it.
force.
Oh, wait a minute. Somebody said pounds. Okay.
We use
So
it as a force.
Pounds. Pounds is a force? Or
Well,
pounds is a mass?
There's pounds mass and pounds force.
Okay, pounds mass. So you're saying pounds. I'm going to all of a sudden turn into red font. Pounds. Pounds, the meaning of mass. Pounds, mass. This is important subscript, okay? Yes, people use pounds for mass. It's a pounds mass. It's not the standard use of mass, but people use it anyways. Okay, good. So let's just go back to blue fonts again. What is the standard unit for length?
It is going to be meters.
No, it's SI. You are in the United States. You don't use meters, huh? Feet?
Feet. Yeah.
Feet or foot? Which one?
Damn, that's hard.
Foot or feet?
Foot.
Well, because English is so weird. If you have only one of those, it's 1 foot. Right? But suppose if you have 2 of them, feet, 2 feet. Suppose if it's 1.5, I don't know, feet. So let's use feet. Do you have any different opinion about that? Well, that's not standard, man. If you work at machine shop, do you actually use feet for every measurement?
Oh, you use inches.
Oh, you use inches, of course. So sometimes people believe, wait a minute, inches are standard. What are you talking about? But inches are not standard. Do not use inches and the numbers associated with inches inside of your calculator. This is a very, very common mistake. You have to be extra careful, but no one uses feet in your drawing. That's the problem. Okay, so what about time here?
Seconds.
Time is the same. Oh, it's the same. In other words, if you go from London to Paris, you don't have to exchange the watch. Well, I keep using British watch. I have to change it to French one. No, you don't have to do that. Time is the same. Great. Okay, now So let's just move down to, okay, force. Force is slightly different because it's made up unit. Okay. So like I said, force is made up by combination of mass and length and time. So if you combine 1 kilogram of mass multiplied by length, 1 meter of length, divided by time is second, okay, second square. Combining all of those standard of mass and length time in SI unit system, 1 kilogram multiplied by 1 meter divided by 1 second square, this should be a standard unit of force. Somebody thought about it. Let's just define something here. This is defined as 1 Newton. So who actually made up this unit? Well, probably this person. 1 Newton, by definition, is a combination of 1 kilogram of mass multiplied by 1 meter of length divided by 1 second square. Okay.
I have a question.
Go ahead.
So during the calculations, for kg, I know there's kgf and kgm, but sometimes it could get confusing when you're putting kilograms over meters.
It's confusing because somebody actually, people, actually not somebody, people use the force unit and no one uses newtons. People use kilogram force, kgf. This is a kilogram. But kilogram of force. Important, subscript is needed. If you don't put the subscript, naturally speaking, people take it as a kilogram as a mass. Okay, but occasionally people say, okay, can I have a 2 kilogram of fish, please? Are you talking about mass or are you talking about the weight, which is a force of a fish? It's a weight or force of a fish is a 2 kilogram force. It is a meaning of force. It's a non-standard use of unit, but people do that all the time. Similar to this pounds mass, people use the pounds all the time, but it's not the standard use. You should be using slugs, but who's using slugs? Nobody. Okay, so I guess you're getting confused, but we just take care of it today, okay? So again, not particularly answering your question, Robert, but let me move on, okay? So force, once again, sorry. So let me just move on force here.
No, so just to be very clear, you can do kilograms and you assume it's kilograms mass, right?
Let's just take care of it, okay, properly, because you probably gonna get confused. Let's take care of it properly. Okay, so let's just move on to US customer unit. The force here, what is the combination of the force here? But first, we are going to use 1 slug because slug is a standard. Combined with 1 feet of length divided by second square. So somebody came up with, well, let's define a standard unit of the force. This is called 1 pound. Okay. Then you go like, wait a minute. Oh, this is 1 pound. This is also a pound. Pound mass, this is pound over force. So oftentimes people use the subscript F, but I don't. If I see pound without subscript, I take it, naturally speaking, it's a pound force because that's the standard use of pounds, similar to the standard use of kilogram. Nobody actually uses kgm. I have never heard of it. Kilogram is a kilogram of mass as a standard. If you want to use kilogram for the meaning of force, always use F subscript, kgf. If you use the pound as a meaning of mass, always use the subscript, pound mass. Okay, so those are the red. You have to be very careful. This is a non-standard use of units. People use that all the time. Let's just quickly take care of the temperature too. Temperature is, again, oftentimes people use, okay, degrees C, Celsius, or degrees F. Those are actually relative scale temperature. So oftentimes in engineering, you have to convert it to Rankine or convert it to Kelvin. Okay.
Do you have those two backwards?
Yeah, I think they're backwards. Rankine is imperial.
That's right. Sorry. Good point. So this is Kelvin, right? And this is Rankine. Okay, good. So let's just move on. Take a look at this example problem quickly, okay, and trying to answer Robert's question. Oh, it's confusing. Are you talking about kilogram meaning of force or kilogram meaning of mass, or you're talking about pounds as a meaning of mass or pounds as meaning of force? Let's just take a look at it, okay? Suppose if you go to Fry's supermarket and measure a bunch of fruit, the scale says 15 pounds. Does this mean 15 pounds mass or 15 pounds force? Anybody?
Force.
Hmm.
Sounds force.
Any objections? Anybody who's taking mass?
No, it's force because of gravity.
I would say it's a mass.
What happens if you have the scale higher up, like in elevation?
Oh, that's a good point. Okay, so let's move on. Suppose if you take this scale to moon, yeah, now you have an argument. Is it mass or force? Because it's going to be different. Okay, anyways, a standard health meter in Japan or any SI unit country indicates everything in kilograms. Suppose if you step onto a Japanese health meter and it indicates 85 kilograms. Oh my God, I'm in trouble. Anyways, does this mean 85 kilogram force or 85 kilogram mass?
Force.
Force? Anybody else?
I think it's mass.
I would say it's mass.
Mass.
You say mass?
Mass for Japan,
Mass.
yes.
Oh, I would say it's force. Anyways, so what's the bottom line? Okay, so let me just demonstrate you using a little bit of space left here. So first of all, if you go to Fry's supermarket and then pick up an apple bag, say 5 pounds, a bag of apple, you just go straight into the customer service and drop that apple in front of the customer service desk and say, hey, I have a question. Is this 5 pound mass or 5 pound force? What kind of response do you think you're going to get?
I work at Fry's. I'm not paid enough to answer that.
Or you may react like, oh, okay, are you entry-level students taking that crazy Japanese professor's class or something, please go home, kind of thing. Or, pounds of pounds, what are you talking about? I don't know what you're talking about. Pounds of pounds? That could be. So you respond like, okay, well, if you say that, I'll take this bag of apple, 5 pounds, 5 pound mass. How about that? Sure, go ahead. Okay, now you said it. Now I'm going to go back here, this page. This is the conversion between standard unit and non-standard unit, okay? Quite important. If somebody used the pound mass, this is not the standard unit, isn't it? So you have to go back to standard unit. This is a slug is a standard. As an engineer, you have to use slugs in your calculation. You have to convert pounds into slugs. One slug is 32.2 pound mass. So, well, now you said it, 5 pounds mass, you said it. Okay, yeah, that's right. So I know weight, which is force, must be mass under the acceleration, which is gravitational acceleration. W equal to mg. Then you said mass is 5 pounds, right? Okay, yeah, 5 pounds mass. Then you quickly realize, wait a sec, 5 pound mass. Pound mass is not the standard. Let's just convert to slugs. Okay, so one slug is 32.2 pound mass. Okay, so I convert it to slug. And then gravity on us, what's the gravity? Oh, that's a 32.2. feet per second square. So what is the value here? Anybody?
That 1 pound of mass is equal to 1 pound
What's
of
the
force.
what's the result? What's the result you get? What's the number you get out of this computation?
5
5 what?
pound force.
Pound force? Do you know why pound force?
Because
Because
the pounds mass cancel and a slug foot per second square is a pound force.
that's right. Slug and feet divided by second square is a pound force. So you go back to customer service rep and say, oh, so that means this is 5 pound force. Yes. Well, but I could have taken 5 pound mass. Yes. But this is 5 pound force. Yes. Pounds are pounds. What are you talking about? 5 pounds? Pounds mass and pound force? I don't care because it's on Earth, you know. This is under the standard gravity. You see that? So pound mass and pound force actually shows the same exact numerical value. So people just don't need to know the difference. You need to know the difference only if you go outside of Earth's gravity, such as moon. Suppose you are a space engineer, spacecraft designer or engineer, you have to know the difference, okay? Or is this pound mass or pound force? Because that's going to be a different value. Because you're talking about different gravity, right? So that's the main confusion comes in. If somebody says pounds, you need to be specifically asked, okay, is that pound mass or pound force? Only engineers will do, probably aerospace engineers only, but you have to do still. Because that differentiation depends on the gravity. If it's happened to be pound force, you are on moon, well, it's going to be different from the value of pound mass contained within. Do you understand that? How much difference, by the way? Suppose if you have a 5 pound of apple, you take it to the moon. Is this 5 pound mass or 5 pound force? It's different things. If you're talking about pound mass, it's still 5 pound mass. Mass never change if you go to moon. But weight will be different. It's 1/6 of a 5 pounds. So the weight is now 5/6 pound force on moon because the gravity is 1/6 of us. But the mass is still 5 pounds mass. Do you understand that? Okay.
Yes.
Okay, I hope so. So let's just take a look at this thing. Okay. So kilogram and kilogram. You go visit Japan, go to fish market, and then try this. Can I have 2 newtons of fish, please? What the hell? Newton? What is Newton? Well, Newton is a standard unit of the weight of the fish. 2 newtons of fish, please. What the hell is that? You mean 2 kilogram of fish? Yeah, not quite, but the 2 kilogram of fish, how's that? Well, it's a lot of fish, but do you still take it? 2 kilogram of fish. How much? Okay, 2 kilogram of fish. Let's use the same equation. Okay. So you say 2 kilogram of fish. Is that the 2 kilogram of mass or 2 kilogram of force?
I think it's force.
It could be mass. The fisherman doesn't care. 2 kilogram of fish is 2 kilogram of fish for the fisherman. You're not an engineer. I'm a fisherman. Fisherman is not an engineer. He doesn't care. So you keep asking questions, Mr. Fisherman in Japan, is this 2 kilogram of mass or is this 2 kilogram of force? I don't freaking care. Take it either way if you want to. Okay, fine. I'll take it as a 2 kilogram force, you know? Is that okay? Yeah, sure. Okay, so how much kilogram mass contained within for the 2 kilogram force, okay, of fish? So you took it 2 kilogram force as a weight, okay? Weight 2 kilogram force must be equal to some kind of kilogram mass multiplied by the gravity on us. Gravity on us, G is what? 9.8? 9.81 meter per second square, isn't it? So from this equation, you can derive how much kilogram do you have. Wait a minute. You cannot do this, you realize. Kilogram force is not the standard. First of all, I have to convert it to newtons because Newton is the standard, isn't it? So let's convert 2 kilogram force into Newton. What is the... So this is the conversion. One is non-standard unit, kilogram force. This is the standard unit, Newton. 9.8 Newton is equal to 1 kilogram force. That's the conversion of units. So having said that, let's just convert kilogram force into newtons. So 2 kilogram force converted to Newton, 9.8 kilogram force. Wait a minute. No, 9.8 Newton is, sorry, 9.8 Newton is 1 kilogram of force. How's that? 1 kilogram force. So this is now the weight of the fish, kilogram force. 5 more minutes. Let's just wrap it up. So this is equal to some kind of kilogram mass contained within under the gravity 9.8 meter per second square. So from this equation, what is the mass in kilogram, anybody?
2 kilogram.
2 kilogram. Okay. So you keep arguing with the fisherman and saying, well, you said this is 2 kilogram. So I took it as a 2 kilogram force. But it's actually mass of 2 kilograms. Is that what you're talking about? The fisherman says, well, I thought it was 2 kilogram force, but this is actually 2 kilogram mass also. Kilogram is kilogram. What the hell are you talking about? Because fisherman is not engineer. He never goes to moon or anything, or he never designed rocket or anything. You are the only one who needs to differentiate kilogram force and kilogram mass because those are two different things. One is mass, one is the weight under the standard gravity of Earth. So if you go to moon, that 2 kilogram force of fish is no longer 2 kilogram force. It's actually 1/6 of 2 kilogram force. The mass is still 2 kilogram. Does it make sense? So what am I talking about here? This is the concept of gravitational engineering unit system. Okay. In other words, your unit depends on the gravity. Gravitational unit system. Bottom line, why this kind of thing came up with, okay? So under the standard gravity of Earth, gravity G, which is 32.2 feet per second square, or 9.81 meter per second square, okay? 1 pound mass have a weight 1 pound force. 1 kilogram of mass have a weight 1 kilogram force. Now you have to be very careful. This is not the standard use of unit, okay? The actual standard is you should be supposed to be using slugs as a standard unit of mass. You should be using newtons as a standard unit of force. But people never do that. Only engineers, aerospace engineers, I would say, use those standard unit slugs and newtons, not anybody else. So people outside of engineering community, they don't care. They keep using pounds and pounds, kilograms and kilograms, mix up. The reason is because the numerical value are the same. 1 kilogram of mass weighs 1 kilogram force. 1 pound mass of mass weighs 1 pound force on Earth. They never leave Earth. But you're an aerospace engineer, too bad. You have to differentiate all the time. So your quiz zero problem 1A, 1B is important practice. You have to do it perfectly, okay? So if you get a great hint out of today's lecture, just go back to quiz zero problem 1A, 1B. Start to figure out, okay? Do you have any question today? Let's just wrap it up. Any question? If not, have a good day. Today's lecture is all recorded, and then it's going to be posted on course homepage. Have a wonderful day.
Dr. Hirosabara?
Yeah.
For the quiz zero, are we supposed to submit it into quiz 1A because there's a 1A folder and 1B folder?
Not the quiz 1A. Those are problems. Problem 1A, problem 1B. Quiz zero is a quiz zero. 14 pages of document. You
Right,
have
but
to submit everything into quiz zero file folder.
oh, okay.
Do not confuse quiz problems and then quiz 1A, 1B. No. Quiz zero is quiz zero.
Yeah, I don't see the quiz zero folder.
Because it's taken. It's due today,
Oh,
12
really?
noon. Yeah, I took it away. Of course, already.
Okay.
Okay.
Okay, thanks.
Okay. Anything else?
I got a quick question.
Go ahead.
Say we forgot to do quiz zero. Is the quiz itself still up there so we can at least work the problems?
Yeah, sure. Uh-huh.
Cool.
I mean, you cannot submit it anymore, but
Yeah, I know.
you can work on it. Sure.
All right, cool.
Mhm.
Thanks.
Anything else?
No, thank you.
All right. Have
Thank
a
you.
good
Thank you,
day.
Dr. H.
Yeah. See you. See you next week. Oh, no. See you Friday. Okay. Sorry.